I received some questions on YouTube about how to make a sheet metal part, and I want to go through the fundamental skills to make a realistic sheet metal part. So let's go onto this plane here and start a sketch. I'm going to grab a rectangle by center, right? And just start from the origin and form my rectangle. From here, I can grab a horizontal and make sure that one of my lines is horizontal. And then I'll grab a dimension, and I'll give this dimension, let's say 16. And we'll go 10. Just like that. Okay. From here, I can grab a tab. So we'll say tab right there. And that forms a base part, or a base tab, right? So we'll grab a flange because we want to add some bends. Grab a flange right there. And just like that, we have made a bend. Now, how do we want to make this? Well, I can say that I want this outer face to align with this edge so that we move the whole sheet metal part back a little bit and have this outer face be the new outside, like that. Or I could say I want this inside face to align with the edge that I just clicked, like that. Or we can say I want the bend, right, this little tangent point of the bend to start at the edge that I just clicked. So I have a few options to have dimensions, and you can kind of see this blue edge that I clicked, how it aligns with that outside face. So here's that blue edge that I clicked, aligning with the outside face, my inside face right there, and then the tangent point of the bend, which that one is my favorite one. That's how I always do it, personally. We can continue clicking. In fact, we can make a little box if we'd like, or I can deselect my edges if I decide that I don't want to do that. Either way, these are how we can make our flanges, and we can vary the distance by putting, say, a 5 there, so now they're all 5 inches up. And again, just like how we did the alignment, we can say, do we want the dimension off of this inside face? Do we want it to be off of the bottom face of our sheet metal part? You can see how we're changing length there as I click between them. Or do we want to measure from that tangent point on the bend, which gives us different options altogether. So you can see how we change length a little bit depending on what we want to measure from. I almost always leave that default because it's my intuition to measure off of this top face when I make the bend. We can have an option to have the bend only. So if I click on bend only, then we just get a little bend right there without any straight. That's really handy when we want to make hems. So I can say 180 if I want to hem it, and there's a pretty handy little hem. Now if I go into the straight, again, we can see that we have a lot of overlap. And so let's address that overlap because, of course, that part can't exist in real life. So we'll go to corners and add a miter. And with our miter, we can see that we've now cut a little gap between our flanges. And we can make our gap width, I don't know, 0.25. We can make it really large if we'd like. And we can change different bend styles. Now I'll make this smaller, maybe 0.05. And we can see how we change the way that we bend things by these different options. So that's how we can create these kinds of miters. Miters are really only going to occur when we're forming these flanges. So I can't click apply and then create another flange and miter that one, right? We miter things all together. So I can make this little pattern. I have no idea how you would bend this particular part in real life, but this does show how we miter things. Okay, so I'll choose this and this, and we can change our angle. What if I did 135, right? That might be achievable. but it's pretty standard to go 90. So, oops. And you say 90 in the angle. Now I also may say I want a flange on this edge, but I don't want it to go the entire edge. So choose a width offset. Now I'm going to remove Now I'm going to do 1 because I can't do this on multiple flanges at the same time. When I do this on multiple flanges, you can see that these options are not editable, and so I'll remove 1 and they become editable. Let's say I want to have it offset 4 inches on one side and 1 inch on the other. You can see that we're changing the length of our flange. So we'll apply what we have there. Now maybe I'd like to have a vent on this face. One easy way to make a vent is to do a rectangle, and I'll choose a distance from this edge where I want this rectangle to be, 0.5 maybe, 0.5. Right, we're just kind of offsetting. Let's go 0.25 there, and then I'm going to cut. And I just push this cut button and it cuts right through. Next, I might want to pattern that, so I'll choose linear pattern up here, and it asks me what path do I want to take, and I'll say I want it to go in the direction of this top edge. So I click on that top edge, and then I say I want these to be 0.5 inches apart, and then I can click the number of instances and make a pretty handy vent. We'll say OK to that. Now, I can always click another edge and add another flange if I'd like. So I'll click on flange, click on my edge here, and apply. I may want to round some of my corners, so I can click on this corner round and click on the edge that makes the corner and smooth things out. I also may want to chamfer. I had a professor that always called it chamfer, so I prefer chamfer, but you know, chamfer is the more popular way of saying it. So you can add chamfers or chamfers there as well. Now I'm going to add some more flanges. I can, again, simply click and apply, or I can change the bend radius. Perhaps I want a very large radius here. I can put a 1 in, and we get a very large radius. And perhaps on this bend I would like to have a cut circle that goes right through that bend. Now that's pretty hard to apply, except for a little secret known as unbend. I can choose a fixed face, right? That'll be my face that doesn't move. And then I'll select this bend and we'll say OK. Except my face needs to be touching the bend that doesn't unbend, so we'll say unbend. Our fixed face will be this one, and then we'll select this bend. Or I can select all bends if I'd like to do that. We'll create a sketch on our unbent face. I'll create that hole. Again, I can give this a dimension of, say, 6 and 4. And we'll make a vertical with our hole center on the origin, and our circle has turned black. And we'll go with a cut, just like that. Now when we're done, we of course don't want to leave it this way. We want a bent part that just had a circle on it. So we can choose rebend, and I'll select all unbent ends. And just like that, we were able to make our bend. Now we have a dimple tool, right? Maybe something gets stamped into our part. So we'll choose this. Dimples do not flat pattern, right? Because sheet metal is based on developable surfaces. So we're going to deactivate this. We're going to go with dimple. And we can choose a depth here. We can go a little bit deeper if we want to, 3 times our thickness or something like that. And when we say OK, we have just a little stamped out section that has some depth right there. Now when I go to flat pattern this, right, this doesn't flatten in the same way because this is more of a forming operation that is not based off of developable surfaces that unbend with sheet metal. These kinds of operations are generally applied before you bend, and so there is the stamping, and then you can do the rest of the operations on the sheet metal part, but that's how that works. All right, we've got a hole tool, so if you don't want to make circles and punch through, we can select a hole. We can even do threads on this, so I can say, you know, ISO fine. We'll choose that face to put a hole on there, and I'll make that a little bit bigger because that is quite small, right? There's a very large threaded hole. Probably too large for it to make sense for this thickness of metal, but you get the idea. When we check modeled, we can actually put in physical threads that are modeled in, and we'll say OK. Now we'll do flat pattern again. We can see that it still flattens out and we still have our physical threads. Pretty brilliant thing. Now we may have to make an eccentric bend, right? I have an existing flange. What if I want to make a diagonal bend across this? Well, that is still straightforward. We can activate a 2D sketch, right? And like one of the ways that we could do it is, because sometimes it can be very helpful to have multiple ways of doing something, is I can just create a sketch, again fully constrain that if you're in a serious project. We'll make a cut, and I better edit my cut here. And I can say through all to make sure we go through. And then I can add a flange right there. But as you can see, we add a new flange, and maybe that's not exactly what we want. So if we want to just fold the corner up, then what I'll do is activate a sketch on this face. I'm going to make a line that goes across, right where I want to bend it. Then we'll choose Sketch Bend. And I'll choose my sketch as the bend line. And there we are, folding the corner up. So that's a great way to be able to, you know, sketch bend your existing sheet metal part. And again, we can flat pattern it to see the dimensions that we want to start out with. Now, when we make these kinds of flanges, right, we can go to, say, our flange menu. We can go to Advanced and see under Bend Allowance that we have the options for K-factor and unfold lengths to do dimensional compensation. The biggest thing is that when we open up our equations right here, we have our K-factor right here set to the correct value. Now we can change our K-factor by going to sheet metal parameters, and 0.33 is a pretty good average K-factor. The material that you're working with will have a K-factor value that will help account for stretching or compressing as things bend. So whatever value you put in there will make sure that your flat pattern has the compensations for compression and stretch through bends. So make sure you have the right K-factor value for the material that you're using, or that you use the unfold length correctly instead. Well, these should be all of the really important ways of making fundamental sheet metal tools. So hopefully this was helpful to the user who asked. If this was helpful, please subscribe, and I'll see you in the next video.